Welcome to my Friday question of the week. I'm going to start this every week as I do my live streams every week on Fridays at 1 p.m. Pacific time. So here I am. I'm going to do an Algebra 2 one. And what I thought I would do as we get along tutoring through the week is that I would get together the most common question I work on that week. Now, I am an online math tutor, and I tutor algebra and geometry, pre-calculus, trigonometry, all that good stuff for high school kids. So if you're interested in any kind of tutoring like that, please let me know. Message me, and I'd be happy to set that up. I still have a few slots available. So I know I didn't promote this the best this week because I'm just testing out my new program that I'm using here today. But I wanted to let you all know that I'm going to start doing every Friday a question of the week. And so this week we are doing maximums and minimums. Yes, that's right, ladies and gentlemen. That's the question I got most often this week. So before I get started on that, let me just tell you a little bit about myself. I was a high school math teacher for 20 years. And I taught the entire curriculum from general math through AP calculus. And then I taught 10 years at a university teaching college algebra and the lower maths too, but basically college algebra. And the last 4 years, I've been tutoring online because I just love working with people one-on-one. And that's what I'm here doing today, helping you all out. So as we get started here, that wasn't the one I wanted. Well. This is important, though, because every Friday at 1, that's when I'm going to be starting my Friday live questions. And that's the address to actually find me. That's my Facebook business page, and that's what I'll be broadcasting. I'll also be broadcasting on YouTube at the same time. So you can also find me over there under Tag Tutoring if you look in YouTube as well. And I'm broadcasting there right now. So I was trying to find where it was that I had this. And now I don't know. Hold on, maybe I can find. Oh, here we go. So I wanted to say, this is me and my technology. As you pop on in here, say hi. Let me know who's here and where you're from. If you do have any questions on the topic that I'm doing each week, please add the question in. If there's topics you'd like me to cover, I'd be totally open to doing those at another time. But this week, I am going to do maximums and minimums. Boy, I'm just trying to get used to all this, you guys. I'm going to catch on to this. Today's my first day using this technology, but I like it so far. So I'm going to share my screen here, and I think I'll do it this way. And here we go. Look, it's like I'm all prepared or something, you guys. So we're going to find maximum and minimums today on quadratics. That's what I got asked the most about. So I have two examples here. The first one, y equals 3x minus 7 squared minus 1. And then the other one there. So the first thing we have to worry about before we can even go to these problems is, what does it mean to be a maximum or minimum, people? And once you get the idea of what that actually means, this really isn't that hard. So we are doing quadratics. And quadratics, every quadratic is of one of these two shapes. It either opens up or opens down, and it's a parabola, right? And if you look here, let me turn my line off. If you look right here, this would be the vertex of the parabola. So that's where it basically hits that point, and then it goes back down that same direction if it opens down like this. If it opens up like the first graph, that would be the vertex. And in this case, it comes down and then it goes right back up again. And that's what the only two shapes you ever get with quadratics. So let's think about this a little bit. Which would be the max? Which would be the minimum? Well, max and mins have to do with the height. So if you want a maximum, here, I'll write it here with my lovely handwriting. A maximum is the highest point on the graph. Let me write it first. And now the thing is, yes, I'm doing quadratics here today, but they don't have to be quadratics. They can be any kind of graph you want. Maximum is still the highest point on the graph. So for us today, We're doing quadratics though. So if I look, and I'm looking at height, so it looks like the highest point goes through there, right? So when you think highest and lowest, I'm not showing you the whole graph, high and low, what goes high and low on a graph? That's the y-axis, right? Not the x-axis. The x-axis goes this way. It goes left and right. So I don't really care about left and right when I'm doing maximums or minimums. I care about high and low. And so I'm going to look on the y-axis. So because every parabola has a vertex on it, would it make more sense to look at the x value or the y value on the vertex? Well, it's the y value. So in this case, the one I'm looking at right now, let me choose a different color. This vertex is at 2, 4. And so this line right here would be y equals 4. And since this is the highest point on the graph, I would say I have a maximum at 4. So first of all, notice that I'm not including the point 2, 4. You don't include the whole point. Maximum's the height, either high or low. So you only give the y value when you state a maximum. So I'll put a note here. Use y value only. Otherwise, you won't get it right. If you give the point, the teacher will probably give you part of the credit, but they won't give you all the credit because you're not really showing that you understand. Okay, so let's go to the other graph that I have up here. I'm choosing hot pink because I can. So, okay, so now the vertex is down here, right? And my vertex is at 7, -1. And again, I want the y value. So it always goes xy, right? So this line must be y equals -1. So the lowest point on this graph must be at -1. Since it's the lowest point, this would be a minimum. So the minimum is the lowest point on the graph. Let me write this. And in this case, I would say I have a minimum at -1. Ooh, that's really hard to read. You guys, my handwriting. My brother, Jeff, used to say, I write like a serial killer, which I never thought was right of him to say, but kind of true, right? So a minimum at -1, that's what I would say on this first graph. So that's nice if you have the graph, and that's cool. You can get it. But I can get the maximum or minimum if I don't have the graph. And I'm going to show you that in a second. I'm going to see if anybody's popped in yet and said hi to me yet. Nobody yet, but I know there's somebody watching. So whoever you are, thank you for coming. So let's take a look now at our next problem. So that's just what a max or min is. Highest point in the graph is a maximum. Lowest point is the minimum. Okay. So now I have 3 equations here, and I don't have the graphs. You're like, oh my gosh, Terry, you're killing me. But I'm not going to kill you, because when we found, I'm going back for a minute, when we found the max and the minimum over here, they all had to do with the vertex, right? So all I need to be able to do to find the max or the min is find the vertex on these. Now, I nicely and politely gave you all of these were in vertex form. I'm not going to lie. Hot pink's kind of giving me life today. I don't know. Kind of making me happy. So if they're in vertex form, you can rip the vertex right out of the equation. And how it goes is you take the number attached to the x and the number on the end to find the vertex. But there's a trick. You have to be really careful. On the x, you always do the opposite of the number. So if they give you a +2, it's actually a -2. And then on the number on the end is always the y, and you don't mess with that. You leave it exactly the same. So let me repeat that. For the x, you do the opposite. I'll put opposite right here. But the y is exactly the same. So very easily, if it's in vertex form, you can find the vertex. So let me just go through here real quick and find the vertex on all 3 of these. So the vertex here, so I'm going to take the number attached to the x and the number on the end. And notice I do not give a darn about that 1/2 in front. I do care about it, but I don't care about it yet. So my vertex is the opposite of the x, the opposite of a -5, which would be 5, and then the number on the end, which would be 1. And just like that, I have the vertex. And then on the last one, I threw this one in because it's a little tricky, only because there's nothing added on the end, right? Well, so if there's nothing added on the end, that's like saying +0. Then I can get the vertex again. So the opposite of the x would be +3, and the number on the end would be 0. And just like that, I have the vertex for all three. Okay, so the next thing we need to worry about is, well, does our parabola open up or down? Now, how do you tell that? So how you tell is also pretty easy once you know what the secret is. The coefficient that's out front here, the 3, the 1/2, and in this case, there's nothing, so I would say it's a 1. These coefficients tell you what's going to happen. So here, I'm going to call this the leading coefficient because that's what it is. The leading coefficient, if I could spell, on this one is 3. The leading coefficient, I'm going to abbreviate to save you my spelling, here is 1/2, and the leading coefficient on this last one is 1. So now I'm going to go back to my first page for a second. And I want to look at how we can tell when the parabola opens up or when it opens down. When it opens up or when it opens down. When I was in the classroom, I used to dance this out, but we don't have enough room here. So this is my crazy way of knowing how to do it. So the leading coefficient in this first one is 3, right? And it's +3, correct? If it's positive, it opens up, is how I remember it on a parabola. Parabola only either open up or they open down. So I think of if it opens up, it's like a smile. If I smiled really big, I'd be forming a parabola. And a smile that opens up is positive. And so whenever you have a positive leading coefficient, it's going to open up. And I care about that because if it opens up, then the vertex will always be a minimum every time. Okay, so then on the second one here, well, the leading coefficient this time is -4. This is my crazy way of remembering this. So if a parabola opens down, it's sad. And I can frown, and I'm making a parabola upside down. And when I do that, that's very negative. To be frowning is negative. And because it's negative and it opens down, the vertex is going to have a maximum. So you don't even care what the number is, that leading coefficient number is. All you care about is the sign. So let's go to our new problems. I know that's goofy, but it always helps me remember it. So in this case, I have a positive leading coefficient, which means without even getting technical and graphing it, I know it opens up because it's a smile, which means my vertex is down here at -2, -5. Okay, and because it's opening up, this vertex is the lowest point, and so this point would be a minimum. Well, the minimum is at the y value here, so it's a minimum at -5. So here's what I did. I got the vertex off the equation. Then I looked at the leading coefficient to see if it's plus or minus. So I would know if the parabola opens up or down. If it opens up, it's a minimum. Okay, so this next middle problem, it's also positive. It also opens up. So then I know my vertex is down here at 5, 1, right? And then so I take the y value, so I have a min at 1. Not too bad, right? And then this last one is positive also. It opens up. Its vertex then's down here at 3, 0. And so it has a min at 0. And that's how you can find the max or the min. If it's in vertex form, boy, you are home free. That's just the best. It'll be the easiest kind to find. The Spanish tutor's here. Yay. Beth is here from Ohio. Welcome aboard. Thanks for coming along to my live stream. I know, Beth, that you're planning a bunch of live streams. She's going to do 30 in 30 days. Now, that is a brave soul. So catch up with Beth. She does Spanish tutoring. So for kids, I think mostly elementary school, but I could be wrong about that. But Beth, you can tell me. So go over to her place, Spanish tutor for kids. And then if you need a Spanish tutor, that's where you go. So there, Beth, you got a nice little plug out of the deal. Okay, so let's keep going here. Uh-oh, what did I just do? Okay, here I am. I'm back. I think I'm back. All right, so let's go to the next page. And then I want to look at two problems. If it's not in vertex form, what do you do? Because then you're like, oh, this is going to be harder. Well, I can do some things that I know, even if it's not in vertex form. I know the leading coefficient here is 3, and you get that off the highest degree and obviously the x squared. So on this one, the leading coefficient, now there's no number there, but it's a minus, right? So I could think of that like a -1. Here, the leading coefficient's -1. Okay, and I only care about that, remember, because I want to know plus or minus. So if it's plus, it's happy, I'm smiling, so I know my parabola has to open up. And then I know the vertex will be down here. I don't know what the vertex is, but I know that that's going to give me a minimum, isn't it? Okay, and then on the other one, the leading coefficient's negative, so that's frowny. Parabola goes upside down. So now my vertex is up here. Now I know that that's the highest point in the graph. So here I have a maximum. So for me to finish this problem, I mean, that's a lot of information right there. Just by the sign of the leading coefficient, you know if your parabola opens up or it opens down. And then you'll know if it's a max or min. Hey, that's half the points on these questions if it's on a test, you guys. So how I would find it if I was going to do these two problems is, let me block this off a little bit here so we have some room to work. I would find the vertex. And let me choose a different color here. So let's do this color. So I'm going to find the vertex. And how I'm going to find it is the magic x equals -b over 2a. Now, what that's going to get me is the x on the vertex. Okay? So how this goes, it goes in order. So if I have y equals 3x squared minus 6x plus 4, I go in order. So a is 3, b is -6, and c is 4. Okay? So now I'm just plugging that in to that equation. I have to change colors because, I don't know, I just like different colors. Okay, so here I'm going to get x equals the opposite of b, which would be b's -6. So it's going to go positive over 2 times my a, which is 3. And then I'm just going to simplify this. So this gives me 6 over 6. So x is 1. So I know, at least on my vertex, that I know x is 1. I don't know my y, but remember, the y is what's going to be the minimum on this one. And how you get that is you plug in the x. And you plug it into the original equation. So I'm going to go y equals 3 times 1 squared minus 6 times 1 plus 4. So everywhere I saw an x in the equation, I plugged in 1 for this because that was what I got out of -b over 2a. Then I'm just going to clean this up. So I'll do exponents first. 3 times 1 minus 6 times 1 plus 4. Then I'm going to multiply. So I'll get 3 minus 6 plus 4. Keep me honest here, people. I think that gives me a 1, doesn't it? 3 minus 6 is -3. -3 plus 4 is 1. So my vertex in this case happened to be 1, 1. So now I know I have a minimum at 1, because remember, you're going to take the y value every time, right? So let me just repeat what we did. So if it's not in vertex form, I do x equals negative b over 2a. You find the x, you plug it in, and you find your y. Whatever you get for your y is your max or your min on the problem. Okay, so let's see if I have any other comments. Okay, so let's keep going here. I want to show you this other one. So I'm going to do the exact same thing again. So let me go back to my other color. So I've got, I'm going to do y equals negative x squared minus 4x plus 1. And I'm using x equals negative b over 2a. Why? Because you can't stop me, you guys. You can't stop me once I start my math. It's too much fun. Okay, so in any case, a is negative 1, b is negative 4, and c is 1. Notice, though, I don't really care what c is. I'm just doing that kind of to round it out. So, okay, so over here, I'm going to get now, let me go back to orange so everything's nice and color-coded for you. So x will be the opposite of b. B is negative 4, so it'd be positive 4 over 2 times a is negative 1. So that gives me 4 over negative 2 or negative 2. So my vertex then, the x value is negative 2. So to get the x, again, you're just plugging it into this formula, negative b over 2a. Now to get the y, I'm going to plug in the x. So now I'm going to get y equals negative. I'm going to be really careful on this one. And I did that on the other one. I'm going to use parentheses when I plug stuff in. Negative 2 squared minus 4 times negative 2 plus 1. The reason I always use parentheses when I plug it in is because you have to follow order of operations. So I have to square this before I give it that negative on the outside. So I'm going to get negative 2 squared is 4 minus 4 times negative 2 plus 1. So I'm going to get y equals negative 4 plus 8 plus 1. Keep me honest, I think that's right. And that will give me negative 4 plus 9 or 5, right? So my y here is 5. Whatever my y is my max or minimum. So my max here is at 5. So it's all a game of, can you find the vertex? And do you know if the parabola opens up or does it open down? Because that will tell you if it's a max or a min. And you do that by telling the sign on the leading coefficient every time. Okay, so that is finding max and minimums. I hope this is helpful. I've been teaching this all week this week. So if you were interested in this Facebook, remember I'm going to be doing this, if I can do it, me and the buttons, every Friday at 1 p.m. Now, it's not always going to be Algebra 2. I also tutor Algebra 1, and I do geometry, and I do pre-calculus. So you never know. If you have a preference, if you have a question that week, go to my page and ask me to explain something, and then on Friday, I'll explain it for you. How's that? So no matter which of those classes you're in, I'll answer your question. All right, and if you're interested in some tutoring, you guys, that's what I am. I'm an online tutor. I love working with people and helping kids. My specialty is building up their confidence in math because I believe every person can learn math. You have to be taught in a style you understand, and that's where I come in. I teach to your learning style. That makes everything easier. And we can do that because we're one-on-one. So if you're interested in that, go to tagtutoring.com, or you can message me either in YouTube if you're watching me on YouTube, or here on Facebook if you're watching me there. Or you can go to my website and do a contact form there. So there you have it, 3 ways to meet. I'd love to help you. I'd love to work with you. I still have a few slots open for right now. So if you're interested in some tutoring, please hop on over. You guys, it's been fun. My first Friday question of the week. I think it's been successful. I'm going to end the broadcast right here. Please, if you find this useful to anyone that you may know, another parent that has a struggling student, please share this video. It would be great. I would love for you to do that. All right, everybody, I'm going to go for now. Have a good weekend, everybody. Stay safe. Bye.